Welcome to our deep dive into motor control using the Omron CP1L PLC. Today, we're tackling a common challenge faced by professionals transitioning from ladder logic to more complex PLC applications. Imagine you're tasked with controlling a brushless motor using the Omron CP1L. You've got your PLC, a BL Super AC servo motor, and a Sanyo Denki RS1A03A driver. The goal is to understand how to effectively use the pulse train output of the CP1L to control your motor. This isn't just about connecting wires, it's about understanding the nuances of pulse generation, signal conversion with the BRINT, a board, and the specific settings required for your driver. We'll break down every step, from configuring the PLC output to troubleshooting common issues like incorrect motor behavior. By the end of this session, you'll have a comprehensive understanding of how to harness the power of the Omron CP1L for precise motor control. To understand pulse train output, imagine it as a series of rapid, consistent electrical signals sent from the PLC to the motor driver. Each pulse corresponds to a specific movement command. The frequency of these pulses determines the speed of the motor. Higher frequency means faster speed, and lower frequency means slower speed. The pulse train output is essentially a digital signal that translates into physical motion. It's crucial to set the correct parameters for pulse frequency and direction to ensure the motor operates as intended. For the Omron CP1L, you'll be working with specific functions like SPED and ACC to control these parameters. Remember, the key to successful motor control lies in the precise timing and sequencing of these pulses. To configure the Omron CP1L for motor control, start by ensuring your hardware connections are correct. Connect the BRINT, a board, to the PLC and the driver. The BRINT, a board, acts as an intermediary, converting signals between the PLC and the driver. On the PLC side, you'll use the 12-pin connector, while on the driver side, use the 8-pin connector. Pay close attention to the datasheets for both the PLC and the driver to ensure accurate pin mapping. Next, configure the PLC settings. Set the output to pulse mode using the specific parameter number 0100. This tells the PLC to generate pulse signals for motor control. For motor direction, use the CW/CCW mode, which is controlled by another parameter. Remember, the CP1L does not have line driver outputs, so ensure you use the appropriate resistors in series with the pulse output to protect the driver from high voltage signals. Now, let's dive into the software configuration. In your PLC program, use the SPED function to set the pulse frequency, which directly controls the motor speed. The ACC function allows you to set the acceleration rate, ensuring smooth motor starts and stops. These functions require specific data registers to be configured correctly. For instance, use D0 for acceleration and D1 for maximum speed. Lastly, ensure the servo on signal is correctly configured to enable motor operation. This signal activates the driver and allows it to respond to pulse signals from the PLC. Now, let's dive into the execution phase of motor control using the Omron CP1L. First, you need to understand the key parameters involved. Set the servo on contact to activate the driver. For the speed function, use SPED 885, and for acceleration, use ACC 888. Remember, the speed parameter is a 32-bit variable, and the acceleration is a 16-bit variable. If you're using pulse and direction mode, ensure your driver is configured correctly. If the motor starts at a standard speed regardless of your settings, check the driver's internal parameters. You might need to adjust these to ensure it responds to the pulse train correctly. And here's a pro tip: if the LEDs on the PLC outputs aren't lighting up, it could mean the PLC isn't emitting any signal, possibly due to incorrect acceleration settings. Now, let's dive into advanced motor control techniques that will elevate your system performance. First, consider implementing velocity profiling. This technique smoothens motor acceleration and deceleration, reducing mechanical stress and improving precision. To achieve this, set the ACC parameter to a lower value, say 50 Hz/4 milliseconds, which will provide a gradual increase in speed. Next, optimize the pulse frequency. A higher pulse frequency, up to the maximum 100 kHz on CP1, ensures finer motor control. Remember, the key to successful motor control lies in the meticulous tuning of these parameters. And here's why that matters. By fine-tuning these settings, you not only enhance motor performance but also extend the lifespan of your mechanical components. This leads us to the importance of regular maintenance checks on your motor and driver to ensure they operate within optimal parameters. One of the most frequent issues in motor control setups is improper signal handling between the PLC and the motor driver. Ensure that the PLC outputs are correctly matched with the driver inputs. If your PLC doesn't have line driver outputs, use a resistor in series with the pulse train output to prevent damage. Another common pitfall is incorrect parameter settings in the motor driver. Always refer to the driver's manual for the correct configuration. For instance, if the motor runs at a default speed regardless of your commands, it might be due to a preset internal speed in the driver. Adjust the driver settings to respond to external pulse inputs. Additionally, pay close attention to the acceleration settings. A high acceleration value might make the changes in speed imperceptible. Lower the acceleration value to observe a more noticeable effect. Lastly, verify that the PLC's pulse output is correctly configured for the driver's input mode, whether it's pulse plus direction or CW/CCW. To master controlling brushless motors with the Omron CP1L, remember these critical steps. First, ensure your driver is correctly configured using the parameterization software. Set the servo on signal to activate the driver. Use the SPED function for immediate speed changes and the ACC function for accelerated speed changes. Remember, the speed is set using a 32-bit variable in HC, with a maximum of 100 kHz for CP1 models. Acceleration is managed with a 16-bit value, specifying the HC increment every 4 milliseconds. Choose between CW/CCW or pulse/steer based on your driver's input configuration. Always follow the manufacturer's guidelines for signal management to avoid damaging the driver's optocouplers. This comprehensive approach ensures precise motor control and optimal performance.